of my favorite games from 2022 is God of War Ragnarok. It might be my favorite game from the last few years as it combines the perfect mix of exploration, action, and story. And the myriad of mechanics that the game introduces was one that I thought was pretty interesting, and that's the Loki mask. It's this little wooden mask that Atreus has in one section of the game in Helheim that tells you the direction of your next objective. You pull out the mask, and depending on if you're looking in the direction of your objective, it'll get brighter and brighter. We're going to recreate this mechanic today in Unreal from scratch using some free assets and existing animations that come with the engine. I'll show you how to edit material properties like emissive brightness in real time, how to edit animations and play them on specific parts of your character's body, and along the way we'll learn how to set up a hold input with Unreal Engine 5's new enhanced input system. What you'll have when you're done with this tutorial is this really cool spellbook that'll shine brighter when you're facing in the direction of your objective and gradually get dimmer as you face away. This should be a pretty jam-packed tutorial with a lot of useful tips and tricks, and you can integrate this into your existing projects without issue. All you need is a way of getting the location of an objective or an object of interest in the world, and this should be pretty plug and play. So with that being said, let's get into Unreal and set this up. Alright, so here I am in my project. This looks a little bit different than the starter third-person template, and all the differences really are cosmetic. So I built a new open play space and changed our playable character mesh. The character blueprint though, the animation blueprint, all the other starter code is the same. So you should be able to follow along with no issues. If you're interested in where to get the Spellbook asset we're using today, I found this on Sketchfab. The creator is Kayla Hill, and it's a free asset for commercial use with attribution. The pirate mesh I'm using on the player character is from the Unreal store. It's a totally free asset. I think it was made free sometime in the last few months, so you can grab this from here if you want. It comes with a bunch of modular pieces to put together if you don't want to use the full costume. So let's start this tutorial by setting up our Spellbook material. If you're going to be using the Spellbook asset, go ahead and upload the FBX file and the textures to Unreal and create a material. You can hook up all the texture maps to the appropriate inputs, and then just make sure the material is set to masked so all the transparent parts are see-through. So to get the effect we want, we're going to make a small change to the emissive texture. Out of this RGB pin, drag out and search for the multiply node, and for the multiply value, we're going to create a parameter. So to do this, just hold down the S key on your keyboard and then click on the graph, and I'm going to name this emissive strength. So we're going to change this value in our game depending on the character's rotation, which will in turn make the emissive material on our Spellbook brighter. So that's all the changes we need to do here. You can save this, and let's move on to creating our animation. So to create our animation for holding out the Spellbook, I'm going to use the existing idle animation with Unreal as our starting point. So let's duplicate it so we don't mess with the original animation, and name it whatever you want, and then double click it to open it. So here we are in the animation editor. You'll need to be able to see all of these bones for what we're about to do. If you don't see them, go up to Character, Bones, and then click on All Hierarchy. Click on the timeline up here to stop the animation, and then we can position our bones accurately. Scrub over to frame 0, so whatever we change on frame 0 will basically apply for the rest of the animation. So let's set up our book holding pose right here with the right hand. I'm going to click on a bone, and it will select the rest of the bones in that hierarchy below it, and I'm going to start rotating it to the right position. So this is very important, but when you're done rotating a bone, click on the key button up here to apply the rotation and basically save your changes for the rest of that animation. So just play around with this until you get the pose that you want, and then save it when you're done. Next up, let's move to our animation blueprint for our character, and we want to create an animation slot to play our right hand animation and then blend that seamlessly with whatever else is playing on the rest of our character at the time. So go to your anim graph, and on the bottom right, let's find the anim slot manager. If you don't see this, click on the default slot in your anim graph, and up here, click on the magnifying glass next to default slot. In the slot manager panel, click on new slot, and I'm going to name this right hand, and then you'll see it pop up in the list below when I click enter. In order to get this into the flow of our pose in the graph, let's disconnect the main states here and save it as a cached pose states. So this lets us use whatever's happening in the main states here somewhere else on the graph. Right click and find that cache pose, so drag out the pin and find the layer blend per bone node. This node will let us pick a bone in our character's skeleton and blend animation seamlessly down that entire bone hierarchy with whatever else is animating and playing on our character at the same time. To continue, copy and paste the cache pose main states again, and out of this pin, drag out and find the slot node. It's going to be the default slot at first, but you can switch that up on the top right, and let's select the new right hand slot we just created. you can put that into the second pin on the layer blend node. From there, connect it to the default slot and let's click compile. Next, we want to set up that bone chain that we want to blend. To do that, click on the layer blend per bone node and add a new branch filter. For our bone name, I'm going to use clavicle R, and I'm going to leave the blend depth at 0. So come back and play with this blend depth value if the animation looks too stiff later on. For now, I'm going to leave it at 0 and see how it looks and come back and change it if we need to. So compile and save your blueprint, and we can finish this section. Alright, so let's tackle setting up our input next. So we're going to use Unreal's new enhanced input system to do this. So navigate to your third person character, input, and the actions folder. I'm going to right click under input and create a new input. This will be called IA Objective Locator. We'll be using this to assign keys and a hold modifier in the next step. So to do this, let's navigate to the input mapping context in the input folder and open the IMC default. This is the container that holds all the input actions of our project. Open up the mappings dropdown and you'll notice the move, look, and the jump inputs are already here. So click on the plus button and let's add the action that we just created. Right below that, you can assign a key, and I'll do the C key on my keyboard, but you can really make this whatever you want. While I'm here, I'll also add the controller option, and I'm going to make this the D-pad up button. The next thing we want to do is add a hold modifier, so this action only triggers when the key is held down for some time. Under triggers, click the plus button and select hold from the dropdown. The default hold time is 1 second, so I'm going to change this to something like 0.5 instead. Also, I'm going to select is one shot so this doesn't keep triggering every frame after the 0.5 seconds has registered. I'm doing the same for the D-pad, and then save and close the IMC, and we're done with this. Back in the character's event graph, we can find the objective locator input action, and out of the triggered pin, we want to get the play montage node. So this will play our newly created animation. You need to tell this node which mesh to play the animation on, so drag over your mesh from the components tab on the left and let's hook that up. So we haven't set up that new animation yet as a montage, so let's do that now. Find the animation asset from earlier, right click on it, and from the create menu, select create anim montage. Now you can search for it and select it in the play montage node, and let's quickly test this in our game. So I'm playing and holding the C key, our character is playing the animation. The transition is a little harsh, it's obviously not blending with the walk animation, and we don't have a good way to stop this at the moment, so let's fix all of that next. I'm going to open the anim montage and adjust the blend in and blend out times here to something like 0.4 to make it a little smoother. This is totally personal preference, so you can play with these values if you need it. Next, let's make sure this montage loops and it doesn't just end when the animation's over after 6-7 seconds. So click on your animation and in the montage sections panel, pick the next section next to default and then pick default again. So now our animation will loop indefinitely. Finally, before we close the montage window, let's change the slot that this is playing in from the default slot to our right-hand slot. So down here on slot and slot name, and then pick the right-hand slot you just created. And let's save this and try this out in game. So now the animation blends with everything else. We can walk and we can run while holding this invisible book. So that's pretty great. The arm looks pretty twisted though, so I'm gonna go in and adjust the original animation a bit to make it look a little more natural. Okay, so that's a lot better. So the last thing in this section is to give us a way to cancel this animation and return to walking or running. So in the event graph, out of canceled, let's select the stop anim montage node and drag in the same montage that we're using above. So to test this now, we hold up the button to bring up the book and press it once again after to return to normal. Cool, so now let's attach the book to our character and get everything ready for the actual glow effect. Alright, so to attach the book to player character, we want to create a socket on our skeleton so the book stays in place when our pirate guy moves around. So go to your character mesh, click on your skeletal mesh asset, and then click on the skeleton button to go to your skeleton tree. I'm going to find the hand R bone, right click it, and add a socket. You can name this whatever you want. I'm going to name this Spellbook socket. Okay, so now that's done, let's go back to our character blueprint and select our mesh in the hierarchy. Find the Spellbook asset and add it as a static mesh and make sure it's a child of your character. With the Spellbook selected on the right hand side, choose the parent socket that you just created, and now our book is attached to our hand. So let's position this properly so we know it's in the right place. First, let's use our new animation as a reference pose. Under the animation mode, change this to use the animation asset instead of the animation blueprint, and then select the animation that we created from the dropdown. Next, we can pause the movement to let us position the book precisely where we want it. So search for pause anims in the right-hand side panel and then tick that box. And now you can click on the book and rotate it and scale it and position it exactly how we want it. So before moving on, let's make sure to unpause anims again on your character and select the use animation blueprint option again, or your character is going to be stuck. So let's compile this and test it, and now you'll see the book is in the right place relative to the hand and it moves correctly with all of our animations. So let's fix the visibility of the book next and add in an effect of it popping into existence. So we'll accomplish this by scaling the book from basically invisible to our correct size over time with a timeline. To start, scale the book down to something very small like 0.01. In our event graph off the montage node, let's add a timeline. So then we'll grab a reference to our spellbook and set the world scale 3D, and then hook this up to the update pin from the timeline. To set the scale value smoothly, we'll use a vector lerp node from 0.01 in the XYZ axis to about 1.44, which was our size of the book before we scaled it to almost nothing in our viewport. For the alpha, we'll use our timeline. So double click on the timeline and let's set the length to 0.5 seconds up here and add a float track. Right click anywhere and add a point to the graph. So set this to time 0 and value 0, but then right click again and add another point, and this time at 0.5, which is the end of our timeline, and then set a value of 1. Click both of these buttons up top to bring up the entire scale into focus, and then zoom out a bit and drag select both points. Right click and select the auto checkbox to make it a smooth curve. So in the event graph, let's hook up this new curve to the alpha of our lerp node. So now we can test this, and you can see that the book pops into view when we do our animation. To make it fade back into nothingness, let's hook up the execution pin from the stop montage node into the reverse node on the timeline. So right now this is scaling linearly, but we can make a really cool pop animation by adjusting the curve in our timeline slightly. Click on the endpoint and drag the control handle slightly down to push the curve up beyond the 1.0 value right before the end of it. So this will make our book increase slightly before coming back down to our desired value. And now we get this nice pop-in effect. So we can polish this a little bit more by having the book completely dissolve before we end our animation montage. To do this, let's connect the canceled pin directly to the reverse pin in the timeline. The timeline node gives us a really handy enum we can use to check which direction it's finished in. Drag out this pin and search for switch on timeline direction, then hook up the finish pin to the execution pin. We can now do something different after it's finished playing forward or backwards. So drag your stop anim montage node here and hook it up to the backwards pin. And now if we test it, you'll see that the book scales out of view before we end the animation montage. Okay, so now we're finally ready to work on the glow mechanic of our spellbook. Let's set up our material to allow us to control it from within our blueprint graph. For this, go to the construction script in your blueprint and drag in your spellbook reference and then search for create dynamic material instance. Under your source material, select the spellbook material and then promote this to a variable. We can now use this inside of our event graph, and let's continue this there. I'll move the timeline node and everything after it a little bit over to give us some space, and then we'll work on the math for the brightness in here. So this is where we'll need something in our world that indicates where the objective is or where the object of interest is. So to make this super simple, I'm going to create an empty actor blueprint to represent my destination, and I'll add a scene component to it called objective location. And then I'll drag this out into my level. So back in the player blueprint, off the montage node, I'll put in a get all actors of class node. From the array pin, I'll get the element at 0 since there's only one, and then I'll promote this to a variable. If you have a system in your project for getting a reference to a destination or an object, you'll just want to replace this variable with whatever that is for you. So after we have this variable set, let's create a timer by event. This timer will check our character's orientation compared to the objective, and then in turn update the glow of our material. So promote this timer to a variable so we can easily cancel it later when it's needed, and then we can hook this back up to the play pin of our timeline. So right below the timer, let's create a new custom event and hook this up to the red pin. Set the timer to 0.1 and make sure that it's set to loop. I'm going to create a new float variable for our final book brightness value after all this math is applied. So let's drag that in all the way to the right and then set that as the output of our new custom event. Alright, so now for the fun part, let's get our objective location and get the world location of that component. Below we can get our actor's current location, and then we find the look at rotation between those two vectors. But this will give us a rotator value that we can now use to check against the rotation of our own actor or character. So get our actor's rotation and then get the delta of those two rotators. And then I'm going to split this structure pin since we're really only interested in the z-axis rotation. So we can now set this as our book brightness and check the value with the print string once we go in game. So you'll notice here when we're facing our objective, the value goes from 0 to 180 on the right and from 0 to negative 180 on the left. So we need to work on this a little bit more to make it usable. We don't want to set our material to a negative value, so let's make this number always be positive. Search for a select float and multiply the z value by -1 for our A pin, and then do nothing for the B pin and just hook up the value straight to it. For our Boolean, which will decide what we multiply the number by, we want to check if this value is less than 0 or greater than 180. Those are our negative ranges right now. So combine them with an AND node and plug that into the Boolean pin. So now let's go back and check this in game, and now we go from 0 to 180 in both directions. 0 to 180 is good, but this range would be better if it was from 0 to 1. So let's map this to that exact range. Pull in a map range clamp node and do -180 to 180 and -1 to 1 for the options. And now in game, looking at our objective, we get a value closer to 1, and looking at the opposite direction, we get a value closer to 0. Alright, so home stretch, let's actually hook this up to our material. So drag out the material reference from your variables and then search for set scalar parameter value. The name of this will be whatever you named the parameter when we set up the material at the start of the video. So in my case, it's emissive strength, so make sure you get this exactly correct in the name field. So our book brightness value going from 0 to 1 won't be enough to make a noticeable difference, so we can multiply this again by whatever we want our max brightness to be. So I'm going to put something like 1500 and then test this out. And now when we face the proper direction, it glows really bright, and it gets dimmer as we face away. So this is all really good, but we have a couple small problems. So one is the value is scaling linearly the closer we get to looking at our objective. So at about the halfway point, we're at 750 brightness, and between 750 and 1500, the brightness is not very different from each other. What we really want is for it to glow much brighter when we're within a few degrees of the objective. We want it really bright when you're in the right zone, and then much dimmer when you're not. To do this, we can do a select float again and choose what value to multiply our book brightness float by. So if it's less than 0.8, meaning you're less than about 20 degrees from looking at the objective, we'll only multiply this value by 75. Anything more than 0.8 and we'll multiply it by 1500. If you want this to be even more precise, you can put a value of 0.9 or 0.95 in here. So let's take a look now, and you'll notice that it's not very bright until we're almost dead center on our objective's location. And then when we move away from it, the fall off is much quicker. So this is looking great so far, but we can do one more thing to make this even smoother. Right now this value is being changed on a timer 10 times per second, and we can move the brightness change to our tick function to make the transition even smoother. So I know tick is usually best avoided, but in this case, because we want to use the float interpolate function, we actually need the event tick. And we'll set it up so it only runs when the timer is active, and it's not doing this all the time. So I'm going to move these last few nodes that we just did to happen before the book brightness value is set. That way we can just interpolate the full brightness when we move to the tick function. I'm going to disconnect the set scalar parameter function and have the book brightness value be the last thing that we set inside this timer. Add the event tick function if you don't already have it, and get a reference to our timer. So check if it's valid, and let's plug this into a branch, and this way it'll only run when the timer is running. So next let's get our spellbook material and get the scalar parameter value of our emissive strength. We're going to plug this into the f-interp node for the current value, and for the target value, we'll get the book brightness variable. We'll set the interp speed to 5, and as always with these nodes, let's get the world delta seconds. And then all of this gets plugged into our set scalar parameter value that we dragged up earlier, and then that's done. All right, so let's test it, and now you can see that the brightness changes much more smoothly if you make drastic changes or big movement rotations. So maybe I'll change this to something like 10 to make it slightly faster. So one final very important point that I missed earlier, even though our book is invisible, we still haven't canceled our timer that checks the rotation, so it's still running all that code in the background. We can go back to where our animation is for ending the mechanic, and let's clear and invalidate our timer. What this is going to do is make sure that the timer, all the math, and the interpolation of our brightness is not happening when we're not actually tracking the objective. Alright, I really hope you guys enjoyed this video and you picked up some tips and tricks on animation, input, and materials. I hope you can put this to good use in your project and let me know in the comments if you have any issues getting it running. I'd love to see anything you set up with this system. If you got any value from this video, it would be awesome if you could hit the like button and subscribe to the channel for more game dev and Unreal videos. More of this type of content and a showcase of the game I'm working on are coming in the next couple months. As always, thank you all for watching, and I'll see you next time.